Last we left with some problems on parallel sailing, in which we talked about a ship sailing along either the latitude or the longitude, and the courses being 090, 270, or 000 or 180 degrees, and the distance made good is either the departure or the delat, and the sum total is delat departure. Now, the principles of parallel sailing is now limited only to be calculating your departure, that is the distance, east and west distance between two meridians, using the formula, parallel sailing formula of departure by d long is equal to cos of latitude. As vessels today sail obliquely from one position to the another, so parallel sailing is no more in practice. Parallel sailing, formula of parallel sailing connects your delat, departure, course, and distance. When two places are in two different latitudes, as you can see L1 and L2, the departure, which is the east-west distance between the two meridians of these 2 points along a rumline track, would be different. Now, the east-west distance between these 2 points cannot be greater than what is the east-west distance here, and it cannot be less than the east-west distance in latitude L2, because your meridians are converging towards the pole. So the east-west distance should lie somewhere between these two meridians, these two latitudes. And that latitude we call it as middle latitude. So the true departure between 2 points on two different latitudes lies on middle latitude. Hence, we can just modify the plain sailing formula for the purpose of plain sailing to departure by d long is equal to cos of mid lat instead of mean lat. Here, except when the d lat is large or the latitudes themselves are very high, the mid lat can be taken as the arithmetic mean, that is, both the latitudes you add and divide by 2, or latitude plus minus half the d lat, without appreciable change. There will not be much error. I suppose you assume the mid lat to be the arithmetic mean. So now this formula, what we have talked about it, we can just modify it again from mid lat to mean latitude. Except if the d lat is large or the latitudes themselves are very high, to assume this formula to be correct for plain sailing would be not correct, as I put all the cross marks here. So if you find that your d lat is too large or you are on very high latitudes, then assuming this to be the formula for finding out your departure or whatever it is would be not absolutely right. Earlier, we used to have some tables to convert mean latitude into middle latitudes. Nowadays, you don't see them much. So I'll just show you these tables here. These were the type of tables what we were seen earlier with the mean latitude, delat, mean latitude, and the corrections were here. Subtract, add. So this is the line of demarcation between adding and subtracting it here. Now just an example here, if suppose the delat is small or your latitudes are not very high. Look at it here. I've got the mean lat, but the delat is not much. I've got my mean latitude by either latitudes divided by 2 or half the delat. And if I go by the formula departure by d long, it's cos lat. So I find the departure to be 205.7. Now if I just wanted to put correction to mean latitude to get my middle latitude, you can see here my D-lat is 6 degrees and my mean lat is 31 degrees somewhere here between these two values. I've just interpolated it here and I've written down plus minus because you can add or subtract depending upon where you are, and I get my mid latitude as 30 degrees 36 minutes. And using this formula again, I calculated my departure and my departure comes to 206.5. Now if you notice, there's not much difference here. Difference is only of about 0.8 miles. But if your D-lat was large, which I'm showing you here in this example here, you are on higher latitudes, your D-lat is also high, D-lat is 20 degrees, you are on higher latitudes, and if you calculated your departure with the formula of departure mean latitude, you'll get a departure of 360 miles. Now if I had to correct it to get to the mean to mid latitude, you can see here my D-lat is 20 degrees and my mean lat is 60. So my correction is 69, which is to be added as per this, and my mid lat is 60 degrees, 61 degrees 09. And calculating my departure, I get my departure as 347.4. So definitely I will call it that there is an appreciable difference between the departures either calculated straight as mean latitude or mid latitude. Now that we don't have this correction, so we can continue to be using this formula up to a distance of 600 miles. It is acceptable. So in case you have a question in which you find your D-lat to be very high or you are in very high latitude, so continue solving with this question would not be absolute, would not be correct, and would be suggested to be solving it with Mercator sailing, which we'll be discussing later. Now we talked about it that a curved line which is cutting all your meridians at the same angle is called a rhumb line, and this is a track what a mariner tries to sail on. Now that we have understood what is your D-lat and departure, we can make use of this understanding to find out our course and distance along the rhumb line track. In this triangle, what we have got here, one side of the triangle is departure, one side of it is D-lat, and using these we can find out course and distance. Now if this line AB is divided into sufficiently large number of small parts, though of course in this diagram you are seeing very big, but that's only for understanding. But if we can draw it, make small number of division into this as small as possible, which I have shown you here with CDE. And if I draw a parallel of latitude from all these respective points, these are parallel of latitudes coming up from here. And we know that the latitudes intersect the longitude at 90 degrees. So these triangles have become right angle triangles. And one side of this triangle is your departure, and one side of your triangle is D-lat. Departure D-lat. If these arcs what I have made, if they're sufficiently small, then all these triangles would have been formed here, like I said, AJC or EGB, will be small and can be treated as plain right angle triangles. In parallel sailing formula, in plain sailing formula, we take into account that the distance between A and B can be divided into large number of plain triangles, and we can use this to calculate our course and distance. So we can find out a course and distance using plain triangles. Yeah. Now, I've written a note. These triangles as plain right angle triangle is no way. I'm not disregarding that the Earth is a sphere. Is not a sphere. But we are just assuming that if these triangles have been made sufficiently small, very small, then they will lie flat on the Earth's surface. And this assumption would hold good up to 600 nautical miles, which is the limit of traverse tables, which we'll be talking about later on. And this formula, what we talked about, departure by D long is equal to cos mean lat instead of mid lat, because as said, the tables to convert mean to mid lat may not be visible to you on your tables. So this holds good up to 600 miles. So thank you. We'll continue with the plain sailing.